Okay, so we're back, and hopefully this is part two. You're still in Algebra 2, not Alex, not Algebra 3, but Algebra 2. And what we're working on here is the next section, or the last section in the chapter 3.2, okay? So we're going to move on from just numbers to now numbers and letters, right? So some people say that's the devil working his way into math when they start mixing letters with numbers, but it's no big deal. Actually, I think that you're going to find that using variables is actually easier than using the numbers because the rules are easier to deal with, okay? So let's look at the first section, and hopefully you already did those homeworks from the last time, right? Hopefully you got done doing this. Okay, you should have done all that either in class or at home, depending on what Miss T wanted to do. And now we're moving on to simplifying expressions with variables. Okay, so let's look at this first one. You're going to handle the letters similarly like you do the numbers. Okay, so okay, for the first one here, we got the cube root is 64 times y to the sixth power. What I'm going to do in cases like this is I'm going to rewrite things. Okay, I'm going to break this up as the cube root of 64 times the cube root of y to the sixth power. I'm allowed to do that. That's a legal operation, okay? But now, the reason I did that is, let me give myself a little more room and I'll show you why I did that. But it does make sense to do this. So, what we're going to do next, okay, so we got those two broke up, and now what we're going to do is we're going to look at what the cube root of 64 is, right? What's the cube root of 64? What times what is 64? If you're not sure, use your calculator, that's fine. And it's going to be 4. Oops, I need the pen. Okay, there we go. It is 4, okay? Now, this over here, there's two ways to look at it. Some people like to look at it like this, where they say, okay, the cube root, and I'm going to rewrite y to the sixth power as y squared cubed, right? Because y squared cubed is y to the second power, or y to the sixth power, right? Because you multiply 3 times 2 gives you 6. And why did you rewrite it like that? Okay, the reason you rewrote it like that is now you have 4 times. What do these 3's do? Let me get my highlighter out and I'll show you what I'm talking about. What happens to these guys? They're both the same. Cube root of something being cubed is just going to be the something, okay? Which is going to make it y squared, and you're done, okay? Now, plan B. This is the way I like to look at it, and you can, do it either way. I don't really care, okay? So I like to look at this. If I have the cube root of y to the sixth power, I like to just say, okay, 3 goes into 6 how many times? Twice, right? You divide 6 by 3, right? So, or if you were to switch it over to exponential form, it would be y to the 6 over 3, which is just y squared, right? So that's what oops, bad 2, really bad 2 there, y squared. So that's the way I like to look at it. I just say, okay, 3 goes into 6 how many times? Twice, so y squared. So you do it however you want to do it. If you want to rewrite it like this and then cancel, that's fine. If you just want to look at it and say, okay, with letters, only with letters now, okay, 3 goes into 6 twice, so it's y squared. Up to you. You do it however you want to do it. Okay, there's multiple ways of doing that same problem. So let me give myself a little more room because I'm kind of bunching these guys together, and we'll do this one next. Let's extend this down. Sorry, probably making you dizzy. All right, we'll just put that one over there for right now. We'll adjust later. Okay, so looking at B now, this is all in exponential form because they're all in exponents. Okay, exponential form is exponents. Now, what I'm going to do here is just like I would do normally. I'm going to take this 1/3 power and I'm going to bring it in to everything. And when I bring it in, what am I going to do? I'm going to multiply it by whatever the exponent is. So that's going to give me 27 to the 1/3 power, right? Times p to what's 3 times 1/3? 3 times 1/3 is just 1. So to the first power. And then what's 12 times 1/3? Okay, or you can also think the 1/3 as dividing by 3. So 12 divided by 3 is 4, so you're going to get q to the fourth power. And you're done. That was easy. Okay, not much to that at all. Well, no, hold on. I'm sorry. I take that back. You're not done. 27 to the 1/3 power is what? Well, if you think about it, that's the cube root of 27, which is 3. So you got 3 times p times q to the fourth power, and you're done. Okay? So, like I said, letters are actually almost easier than numbers. Okay? So let's bump to this one. Now, if I'm looking at this, what can I do to make this maybe a little prettier? Well, the first thing I might think about doing is breaking them apart because I like to handle things in pieces. So I'm going to do this divided by the fourth root of n to the eighth. Okay? So why did I break them apart? Well, I broke them apart because now I can kind of see it a little bit better. All right. Well, if you're here, let me get my highlighter out. I'll kind of talk about. You have a 4 and a 4. So what happens there? What's the fourth root of m to the fourth power? Well, that's just going to be, it undoes the 4's, right? The 4's undo each other. It just leaves you with m, okay, on the top. So that was easy. Now the bottom, a little bit trickier, okay? This is where you can, again, go back up to the last problem we did. You can ask yourself, how can I rewrite n so that it's going to have a 4 on the outside? Well, that would be n squared to the fourth power, and then the 4's would cancel, you get n squared. Now, the way I like to do it, and, again, it's up to you, no right way or right or wrong way. I ask myself, how many times can 4 go into 8? Well, 4 can go into 8 twice, so that's just going to be n squared. Does that make sense? Is that easy? I like that better. Okay, you make your call though. If you wanted to, the alternative route, let me write the alternative route just in case you liked it better the other way. You would take this bottom, okay, and you would say, okay, I'm going to break that down like this. This is the other way of doing it. You would say n squared to the fourth power, right? And then you would say, okay, look, I got fourth, 4, so they cancel, you just get n squared. That's in yellow, and I'm sure you can't see that, but that's fine. Okay? So either way, but this is your final answer right there. Okay? Ooh, yeah. All right, now moving on to the next problem. If you're looking at division, the easiest way to handle this in my mind is do the numbers first. Okay? So let's do numbers with numbers, and letters are a whole different ballgame. Okay, so look, you got 14 and 2, right? What's 14 divided by 2? Yes, very good. You guys are on top of your game. 14 divided by 2 is 7. Okay? Now, we're going to bounce over to the next one, which you're going to have an x and an x. So let's go here. Let me get colors. There you go. You got x to the 3/4 power and just x to the first power. So what's the rule when you have an exponents on the top and the bottom, same base? Okay? Good. Keep the base, subtract the exponents. That's the rule. Okay? So I'm going to keep the base, which is x, and I'm going to subtract the exponents, which is just 1 minus 3/4. Hopefully you're getting better with your fractions, and we'll work that out on the next step. Now, the next one is going to be the y to the 1/3 power. Well, there's nobody for him to subtract to, so he's just going to stay right where he is. There's nothing you can do with him. You just leave him alone. So that's going to be y to the 1/3 power because he's not going anywhere. He has nobody to subtract with. He's fine. Now, the last one you got to work with, and you got to do a little bit of manipulating with him, is z to the negative 1/6 power. Because what does a negative exponent mean? Yes, yes, very good. You have to move him to the top of the fraction. So he is going to come up here and make it z to the 6. So that's going to be z to the sixth power. Okay, so now we're almost done. The only thing I have to simplify is this little guy in here, and we're done. So we're going to have 7. He's out front. I'm going to have x to the 1 minus 3 quarters, which is going to leave you 1 quarter. And you're going to have y to the 1/3 power, and z to the sixth power. Bad z, but you get the idea. Okay. All right, and then that's it. So hopefully you're starting to see the letters are actually easier than numbers. That's why we like them better. Okay, so moving on to a couple practice problems. Why don't you give these 3 a shot by yourself? And we'll see how you do, and we'll go from there. Okay? So go ahead and pause the video. Okay, and you're back. So you unpause the video and you're ready to see if you got these right. So let's look at the first one. Okay, you got um, you're going to want to break these in pieces. So if I'm looking at the first one, that fourth root or the fifth root of 4, that's not going anywhere. So I'm just going to leave these the first step alone. He's not going anywhere because that won't break down, right? There's no number multiplied by itself 5 times to get you 4. Well, there actually is, but yeah, we'll just leave that alone. There's no nice number that does that, okay? Now, how about a to the 8th power? This one's going to be a little bit tricky. So here, we'll just handle it separately. 5a to the 8th. What you're going to ask yourself on that, and we'll do that on the next step, is what do I have to multiply, or how many times is 5 going to 8 once, and how much is left over? So we'll talk about that in a sec. Next one is going to be to the, I'm just going to do them all separately. B to the 14th power. Last one's going to be C to the 5th power. Oh, that one's easy. Hopefully you got that. Okay, so this guy's going to stay, right? So we're just going to keep him alone. All right. Now, how many times can um, 5 go into 8? It can go in once, right? How much is left over? 3, right? So if it goes in once, that's a to the first power, right? You don't have to write the 1, but I did just to show you. How much is left over? There's 3 things left over, right? So you're going to leave those 3 inside. That might be a little confusing. Have somebody next to you clarify there, okay? That's kind of tricky. So 5 goes into 8 one time. That's the 1. How much is left over? 3. So that stays inside. Okay, next one. How many times does 5 go into 14? Well, it goes in twice. Okay, so you're going to have a b squared. And how much is left over? Well, 4 is left over. So you're going to have the 5th root of b to the 4th power. Now, last time. Well, how many times is 5 going to 5? Once, so you just get C. All right, now, final answer. Now, this is the part you got to make sure you keep outsides with outsides, insides without insides. So here's an inside, inside, inside. Here is an outside. Where's my thing at? Hey, hey. I lost my cursor there, sorry. Outside. Hmm, hang tight. Let me pause this real quick. Sorry about that. Okay, so we did all the insides, now I'll do the outsides in blue. So that's outside C, outside here, outside there, and we're done. So let's write them all together. Outsides with outsides, insides with insides. We have an a C, and a B squared, okay? Insides, just make one big inside, okay? 5th root of 4 times a cubed times b to the 4th power. And then you're done, okay? All right, so that's your final answer there. Hopefully you did okay on that one. Let's try this next one. Here, let me get this guy out of the way. We'll move him over here. Move this guy down a little bit. Give myself some more room. Okay, so let's do these two. We'll see how you did. Okay. So this one, if you're looking at this one and you're trying to figure out what you need there, the best thing to do is maybe separate them. Because if you separate them like this, the cube root of x on the top and the cube root of y to the eighth on the bottom, and you ask yourself, can um, how many times can 3 go into 8? Well, it can go in 2 times with 2 left over. So the top, well, not much I can do about that. So that might already be done. But the bottom, I'm going to get a y squared outside because it goes in twice. I'm going to have one of these left over. Okay, so we would be done, but what's the problem? Exactly. The problem is we have an extra radical, okay, on the bottom. Oh, this should be a 3, I'm sorry. We have an extra radical on the bottom, which I can't have. So what I'm going to do is I'm going to multiply both the top and the bottom. I'm rationalizing the denominator by this. It's kind of a weird thing to do, but it's just fine. Hear my daughter in the background there. All right, so now, what happens when you multiply this guy with this guy? What do you get? Right, you just get a y, right? So I'm going to have, we'll just separate this into an extra line. So I'm going to have y squared times y on the bottom because this guy times this guy is just y. Now on the top, well, you're just going to have this. So that's going to be the cube root of xy. And now for your final answer, you should combine the bottom, make it y cubed. On the top, just make it the cube root of xy. And then you're done, okay? So there's nothing else to it. So that's your final answer right there. Okay, a little tricky, but let's try the next one. Let's see how you do. All right, so the next one looks like it's really, really easy. What's the cube root of 27? Good answer. Who was that? Rob? Rob answer that? Probably not. All right, so let's see. And this is the cube root of q to the ninth power. All right, so this is going to be 3. All right, and then how many times does 3 go into q or go into 9? It goes in 3 times. So that's going to be q to the third power. And that was easy as pie. Okay, that was really, really easy. Okay, good. One last problem. Let's see how we're doing. Okay, one last problem. We got this one right here. So if you're looking at this, you might want to separate the two. So if I break, you don't have to separate the two. If you want to do it in one step, I'm fine with that. Just make sure you get the right answer. Okay, divided by the fifth root. Yeah, because you might have saw this one right off the bat, which is okay. All right, so how many times does 5 go into 10? Well, it goes in twice. That gives you x squared, right? How many times does 5 go into 5? Once. So that's just y. That was easy. Okay, so that's your final answer right there. All right, so that's the couple practice problems I wanted you to try. I got one more section of problems, and then that is it. I think it's just these 3. Let me double check. 3 practice for you too. Okay, so these are going to be even easier. Addition and subtraction is pretty easy. So we're just using the same thing with variables, the same thing as we did yesterday or earlier today, just with variables. So let's look at these ones right here. I've got w, square root of w, square root of w. So we're just going to keep the square root of w as the thing I'm adding together, right? And then I'm going to add the coefficients. So what's the coefficients? I got a fifth plus 3/5. So 1/5 plus 3/5 happens to be 4/5, and you're done. Easy, okay? All right, same back sides. Again, nice. How nice is that? So nice. Mr. Scott, are you awake? All right, I'm just making sure. Mr. Scott better have his head up. Okay. All right, so same back sides. Yellow, yellow. Now we're going to add these two together. All right, so fronts are blue and blue. So what's 3 minus 8? Very good. 3 minus 8 is going to be negative 5. And then we're going to have x, y to the 1/4 power. And you're done. Okay? So it's pretty easy. Now, let's try this one. This one's a little bit... Why can't I just directly add these together? Because some things need broken down, right? So you want to break these down as far as they'll go first. So if I'm looking at this first one, I'll leave the 12 outside. And then the cube root of 2 will be one part, and then the cube root of z to the fifth will be the other part, okay? Now, I'm going to subtract this side, so z staying outside. I'll have the cube root of 54 times the cube root of z squared, and I'm going to break down anything I can break down. So if I'm looking at this, what will break down? That's not going to break down. This looks like it should break down a little bit. This looks like it has the possibility of breaking down. So I'm going to handle those two things next. Okay, so let's look at this. 12 um, cube root, oh gosh, this is going to get sloppy. Cube root of 2, here, let me get that out of there. Cube root of 2, okay, and then how many times does 3 go into 5? 3 goes into 5 once with how much left over? With 2 left over. So it's going to be z cube root of z squared, okay, minus z times, all right, here we go. 54, is that a perfect cube? I don't know. Let me go to my chart here. Perfect cube, I don't see 54 on there, but do you see some number in here that might multiply to 54? Right there, 27. Okay, so that's what I'm going to use. So I can break this up as the cube root of 27 times the cube root of 2. I'm allowed to do that, right? That's the blue section I broke up. And then this guy, there's not much I could do with him, so I'm just going to leave him alone. Okay? Now, to this side. All right, because remember, we got two pieces here. You got yellow piece, which is right here, and you got green piece. So these are two separate guys, so we want to combine them separately. All right, so let's finish combining these two together. You got, over here, you're going to have 12 z cube root of 2z squared. That's what you're going to have on this side. Insides with insides, outsides with outsides. Now I'm going to subtract this green piece. Well, this green piece needs a little bit more breaking down. This 27, the cube root of 27, is going to be a 3, okay? That is not going to break down at all. The cube root of 2 just stays alone. So you're going to have 3 from this thing, okay? And then you're going to have the z, that's outside. And then you're going to have the cube root of 2z squared. Oh, look how nice that is. All right. So why is that so nice? Because the backside here is the same as the backside here. Okay. So all we're going to do is combine our like terms. Sorry, my kid wants in on this video. All right. So 12z minus 3z, right? What's 12 minus 3? That's going to be 9. So you have 9z, and then the same backside. So cube root of 2z squared. So yeah, a lot of ugly work there, but that's your final answer. That's not too bad. So hopefully you did okay with that. All right, these three are for you to try, and then we'll go over them. So go ahead and pause it. Try those three right there, and we'll come back and try it. Okay, good job. So hopefully you tried those. Let's go over them together. Okay, if you look at the first one, can you break down this is really a 2 here, okay, and really a 2 here. Let's see if we can break that down. What's the square root of 9? 3. Good. How many times can 2 go into 5? Well, it can go in twice with 1 left over. So that's going to be a w squared with a square root of w on the inside, okay? That's the 1 left over. 2 in twice, 1 left over. Now, over here, how many times can 2 go into 3? Once with 1 left over. So, but you already have a w out there. So you're going to pull a w out, and you have a w out there. So that's going to give you a w squared outside, okay? With a square root of w inside. Okay. How nice is that? The outsides or the backsides match. So you're just going to combine the terms together, okay? Okay, so 3w squared minus w squared is going to be 2w squared with the square root of w on the backside, and you're done. That's a w. It's ugly, but it's a w. Okay, let me pause this real quick and handle that. Okay, I think the kids are somewhat dealt with. So let's try this. Next problem. All right, the fourth root of 4 or 243. What is that? Well, let's look at our little cheat sheet. What did I say? 243? 243. Hmm. Can you find a number on here that is divisible by two, that will multiply into 243? So try 1. 1 works, obviously, but we don't want to use 1. We want to try to use something that's a little more, um, that's bigger. So maybe 16. So 243 divided by 16. No, that ain't going to work. We don't want that. So let's try 81 maybe. 243 divided by 81. I got 3. So that's what I want to use. I want to use this 3, okay, or 81, okay? So I'm going to break this guy down to the fourth root of 81 times the fourth root of 3, okay? And I did that on purpose because 81 is going to break down nice. Okay, so now I'm going to subtract that, 48. Well, 48 is also not on my list, but we know 48 divided by 16, which was on my list, is 3. So, oh, isn't that nice? Okay, so I'm going to have the fourth root of 16 times the fourth root of 3. Well, looky here. Looky, looky. We got same backsides. Perfect. All right, now, so I'm going to break this down. This is really, what did I say? The fourth root of 81 was 3, right? Yeah, 3. Okay. So that's 3. This is 3, fourth root of 3. And this is 2, fourth root of 3, which gives me 1, fourth root of 3. And that's my final answer. That's a bad 3. Sorry. But that's what it is. Okay. Now, last problem. Okay. Last problem for the day. Let's see if we can get this in. All right. All right. If you're looking at this one, oh, you know what? It's actually already set up. This is almost like a trick question. I was immediately starting to think I want to get rid of those fractions, but maybe I don't. These are the same backside. So all I'm going to do is add the fractions together. Yeah. So a fifth plus a tenth. Now, that's a little tricky. You might not be able to do that in your head. So let's think about it. If I made uh, this one as a tenth, 1/5 is equal to what? 2/10. So I have 2/10, a squared b plus. You could just do that on your calculator if you didn't get that, because your calculator will do those nice fractions for you, unfortunately. Okay, so same backsides. I got 2/10 plus a tenth, which gives me 3/10, and a squared b, and you're done. That was easy. All right, so that should do it for today. So what I want you to do for the remainder of this period, depending on how well you got it, so just like before, if you feel like you got a good hand on it, and I'll let Mrs. T make that call. If you guys feel like you got it, I want you to do these problems for homework. If you feel like you're still struggling with these problems, what I want you to do is work on these in class today for whatever's left over, and then we'll pick up tomorrow. I want you to finish the rest of the problems in class. You can use your partner, whatever you need to do, and um, and then we'll start the next day by checking over your homework. So try these problems either in class or for homework, depending on what Mrs. T says. That's her call. Okay, they're odds. They are in the back of the book, but after you pause the video, I would pause the video, and then when you're done, I got the answers. So go ahead and pause the video. Either try it in class or do it for homework, and then starting the next day, when you unpause the video, I'll lower the thing. So go ahead and pause it. Okay, you're back, and here are your answers. So hopefully you can see that. Sorry, Monica, still in pink. Nothing I could do. Okay, so I have Kayla read them to you. All right, so there's the end of 3.2. We're done. So the following day, after you guys have completed this homework and you feel comfortable, I want you to try the worksheet I have copies for. It's 3.2 Practice B. It's a review of all 3.2, so everything on there. Remember, I make these reviews. These reviews I make them very similar to my my quizzes. So you should probably expect like similar problems on the quiz. If you could do okay on that review, then you should be okay. If not, then might need to practice a little bit more. Mrs. T has the answers to these, so she can help you out and let you know if you're right or wrong. Okay? And I want you to collect all, or not collect, but keep all of your homework and all of these practice problems. When I come back, we're gonna have a grading frenzy where I give you guys all kinds of crap loads of points. So make sure you're keeping this, and then the next day we'll move on to 3.3 Part A. Okay? Okay. Have a good day.